So in this video we'll do the problem related to the volumetric strain. Okay. In the previous video we derived the equation for the volumetric strain. If rectangular block is there, if it is subjected to different stresses like 3 stresses in x direction, y direction, z direction, what is the total volumetric strain? Just I'll recall that one. That is total volumetric strain. We derived that if it is subjected to sigma x, sigma y and sigma z in 3 mutual perpendicular directions, then the total volumetric strain is, that is sigma x plus sigma y plus sigma z into 1 minus 2 nu. We derived this one divided by E, where E is Young's modulus and nu is the Poisson's ratio. So here now, depending upon this formula and everything, we'll solve the problem here. Okay. First I'll read the problem, then we will go step by step. A block of size 200 mm into 80 into 20 mm. That is, a block is there, its length is 200 mm, width is 80 mm and the thickness is 20 mm. Is subjected to the forces as shown in figure. It is subjected to the forces in different direction. In x direction it is 250 kilonewton tensile nature. In y direction it is subjected to 180 kilonewton, it is compression. In z direction it is subjected to the force of 300 kilonewton, it is tensile nature. Okay, these forces it will be acted here shown in figure. Determine change in dimensions. We need to find out how much change in length of the block, how much change in width of the block, how much change in thickness of the block, that we need to determine. Next, change in volume, total overall volume, how much we need to find out here. First we'll note down the data here. A block of size 200 mm. What is 200? Length. That is L equal to 200 mm. It is data given. 80 mm. The width is 80 mm. That is B equal to 80 millimeter. And thickness is 20 millimeter. T equal to 20 millimeter. Is subjected to the forces. In x direction, how much it is acting here? 250 kilonewton. That is Fx. I will write force in x direction is plus 250 because it is kilonewton. It is tensile nature. This I'll write it 250 into 10 raised to 3. 10 raised to 3 Newton. Okay. Next, in the y direction, how much is the force here? 180 kilonewton. It is compression. Compression means it is negative. Therefore, Fy, force in y direction, is 180 kilonewton. Minus, it is minus 180 kilonewton. That will be equal to minus 180 into 10 raised to 3. 10 raised to 3 Newton. Okay. In the z direction, how much it is acting here? That is plus 300 kilonewton because it is tensile nature. That is Fz equal to plus 300 kilonewton. That will be equal to plus 300 into 10 raised to 3 Newton. Because I want in Newton, so I converted. Okay, next, what is the next data? As shown in figure. You need to find out the change in dimensions, change in volume. Next, take E equal to 200 GPa. What is E? Young's modulus. E equal to 200 GPa. I want this into MPa, megapascal. That again same Newton per mm square. This will be equal to 200 into 10 raised to 3 MPa. Okay. This I will write it as 2 into 10 raised to 5 MPa, megapascal, or it is Newton per mm square. Both are same. I want force in Newton, other data, the linear dimensions in mm. Okay. This is Young's modulus. And what other data is given? Poisson's ratio. That is nu equal to 0.3. Poisson's ratio. Okay, we need to find out change in dimensions, change in length. Along the length, I need to find out change in length in x direction is how much. Okay, next in y direction, how much it will be changed in dimension. That is, this is also called as deformation. Deformation in x direction. Okay, again, change in length in y direction is how much, and change in length in z direction is how much. That is first bit. Later we will go the second bit here. Okay, these are all the data is given. Now, how we need to start? How we need to find out the change in length? First, I'll take first change in deformation, change in length. Okay, we have the formula for change in length. Where, in which formula it will comes here? That is, we know that normal formula, strain equal to change in length divided by original length. This is normal formula. Okay, so that is strain, we know that strain equal to change in length divided by original length. If you consider along the length, it is change in length in x direction. Okay, so length. So I want this one, change in length in x direction. I know the length, this is in x. I know the length. Length is how much? 200. But I don't know the strain in x direction. So I need to find out strain in x direction. If I find out the strain in x direction, I know the length, easily I can find out the deformation or change in length in x direction. How to find out this one here? Okay, so to find strain in x direction, what is the formula? Normal formula is stress by strain equal to E. Stress by strain equal to E. Directly I will apply. But this is related to, again, you need to apply for y direction and z direction here. So I will write this one here. So epsilon x equal to stress by E. What? Stress in x direction. Stress in the x direction divided by E. This is related to this. It also affects y and z direction. Minus nu into stress in y direction divided by E minus nu into stress in z direction divided by E here. Okay, to find out strain in x direction. So to find out this one, I want stress in, I know E, Young's modulus already he is given 2 into 10 raised to 5, and Poisson's ratio 0.3, that is 0.3 is given. So I want to find out first stress in x direction, stress in y direction, stress in z direction. Okay, to find that one, first one by one I will go. Stress in x direction equal to load by area. Okay, load in x direction, right? So this I will write, load in x direction is how much? Plus, it is fx. Fx is plus 250 into 10 raised to 3. 250 into 10 raised to 3 plus divided by area. Area, which one you need to consider? This is x, along x, this one 250 it is acting. Perpendicular to this load, we need to check the area. Which one is the perpendicular to this load? The area is this into this here, right? That is, I want 80 into 20, right? 80, this is 80 and this is 20, because this is width is 80 into 20, that is 80 into 20 mm. This will be equal to, after calculation, I am getting 156.3 MPa. Okay, this is sigma x. Now calculate sigma y. For stress in y direction, what is the formula? Load in y direction divided by area perpendicular to y. Area perpendicular to y. Now, what is the load in y direction? Load in y direction, how much is there? That is 180. 180 into 10 raised to 3. 180 into 10 raised to 3 here. It is minus because it is compression. So, minus 180 into 10 raised to 3. This is load in y direction divided by area is, now this is y. Which area you need to consider? Perpendicular to this y. This and this, right? This is this and this. This is how much is there? That is 80. And how about this one? What is this dimension? It is 200, right? I will take 80 into 200. 80 into 200. That is 80 into 200. Right? So, after calculation, I will get this one is, that is minus 11.3. Minus 11.3 MPa. Because it is compression. Now come to the stress in z direction. Stress in z direction, this direction. So load in z direction divided by area perpendicular to z. Load in z direction divided by area. Area. Okay. Now this will be equal to, load in z direction is 300 into 10 raised to 3. Load in z direction is plus, it is tensile nature, plus 300 into 10 raised to 3. That is plus 300 into 10 raised to 3 Newton divided by area. Area perpendicular to 300. This area, right? This area. This area is 200 into 20, right? Exactly to z direction, this area. 200 into 20. That is 200 into 20. Okay? 200 into 20. If you calculate this one, I will get this, you will get the answer 75 MPa. 75 MPa. Okay? Now you found stress in x direction, stress in y direction, and stress in z direction. These are the values. Once if you find out these sigma x, sigma y, and sigma z, what is the next step? Come to the strain. Strain in x direction, strain in y direction, and strain in z direction. Now I will go one by one. Strain in x direction. Strain in x direction is sigma x divided by E minus nu into sigma y divided by E minus nu into sigma z divided by E. This formula we already derived in the previous video. Okay. Now I will substitute. Stress in x direction is 156.3. I will take E as a common. That is 1 by E sigma x minus nu into sigma y minus nu into sigma z. Okay. This will be equal to 1 divided by E is how much? Young's modulus. Young's modulus 2 into 10 raised to 3 MPa. 2 into 10 raised to 3 Newton per mm square into stress in x direction is 156.3 minus nu. Poisson's ratio is 0.3. He is given Poisson's ratio, that is 0.3. Next, stress in y direction sigma y minus 11.3 minus 11.3 minus nu is 0.3, sigma z is 75, that is 75. Okay. After substitution, after simplification, I will get the value, that is 68.6 into 10 raised to minus 5. Do I have any unit here? No. Change in length divided by original length. Strain, normally the formula is change in length divided by original length. The mm and mm or the unit, it will be cancels. It has no unit. So strain in x direction. Okay. When once if I find out strain in x direction, substitute here strain in x direction and length. I can find out the deformation in length, total how much change in length in x direction. Therefore, strain in x direction equal to change in length in x direction divided by L. I know the strain in x direction is 68.6 into 10 raised to minus 5 equal to, I want the change in length in x direction. Change in length in x direction divided by length is how much? Length is 200. That is 200. Therefore, change in length in x direction equal to 0.14 mm, 0.14 millimeter. Okay, this is change only first bit, change in dimension in length, only in length in x direction. Now again I'll go how much dimension change in y direction. Okay, now also in y direction, change in length in y direction divided by original length equal to strain in y direction. Okay, I know length. What is the length here? Length means it is width, because this is related to the y direction here, that is y direction. Okay, this will be thickness, comes to the thickness. This will be equal to change in length in y direction divided by, it is comes to the thickness, because how much this will changes here. Okay, related to thickness equal to the strain in y direction. Now you need to find out strain in y direction. Strain in y direction is, what is the formula? That is stress in y direction divided by E minus nu into stress in x direction divided by E minus nu into stress in z direction divided by E. Okay, this 1 by E I will take outside. Stress in y direction minus nu into stress in x direction minus nu into stress in z direction. Okay, now substitute. 1 by E is how much? Young's modulus 2 into 10 raised to 5. 2 into 10 raised to 5 Newton per mm square. Stress in y direction is minus 11.3 minus nu is how much? Poisson's ratio 0.3. 0.3. Sigma x is 156.3 minus, again nu is 0.3. Stress in z direction is 75. Okay, so this will be equal to, after calculation, strain in y direction is minus 40.35 into 10 raised to minus 5 into 10 raised to minus 5. No unit. Okay, strain in y direction. Once if you find out this one, you need to come here. Substitute this value here. Therefore, I want change in length in y direction. Change in length in y direction divided by thickness is how much? 20 millimeter. Thickness is 20 because I am applying here, its thickness is 20 millimeter. 20 equal to strain in y direction is how much? Minus 40.35 into 10 raised to minus 5. Okay. After calculation, find out unknown value, that is change in length in y direction is minus 0.0081 millimeter. Okay, very small in y direction because thickness is also less, and this is the deformation or change in length in y direction. Okay, now what is the next step? We need to find out how much in z direction, what is the deformation or change in length. Okay, next step is to find change in length in z direction. What is the formula? Change in length in z direction divided by original length. What is the original length in z direction? This is the original length, that is width. It is b. I will take this one as b. This is original length. I want to find out how much it's changing here. Change in length divided by original length in z direction equal to strain in z direction. I know width is 80 mm. I don't know strain in z direction to calculate this one, right? So now we need to find out strain in z direction. Strain in z direction equal to what is the formula? Stress in z direction divided by E. Minus nu into stress in x direction divided by E minus nu into stress in y direction divided by E. Okay, this we are frequently using these formulas. Okay, next, if I take the 1 by E as a common, this it will get sigma z minus nu into sigma x minus nu into sigma y. Okay, substitute the values now. 1 divided by Young's modulus. E is how much? 2 into 10 raised to 5. 2 into 10 raised to 5. I am substituting. Next, sigma z is 75 MPa. That is stress in z direction. 75 minus nu I know already, Poisson's ratio 0.3, and sigma x is 156.3 minus nu is 0.3, sigma y is strain in y direction, it is minus 11.3. Okay, after simplification you will get strain in z direction is 15.75 into 10 raised to minus 5. This is strain in z direction. Okay, when once if you find out the strain in z direction, go to this formula here, substitute strain in z direction, substitute width, you will get total how much, the total change in length in z direction. Therefore I don't know the change, I want the change in length in z direction, that is deformation in z direction, divided by width is how much? Width is 80 millimeter. Right? That is 80 equal to what is the strain in z direction? 15.75 into 10 raised to minus 5. Okay, now find out the unknown value. strain in z direction, that is sorry, deformation in z direction or change in length in z direction equal to, after calculation you will get 0.013 millimeter. Okay, this is how you need to this is for first bit. The answer for first bit I will write once again. Change in dimension, he is asked change in dimension, so I calculated change in dimension in x direction, y direction, z direction. Therefore for first bit solution, change in length in x direction equal to what I calculated before here, and that is 0.14, right, 0.14 millimeter, and change in length in y direction I am getting here minus, because it is compression, 0.00, how much I got here, 0.0081 millimeter, and in z direction, change in length in z direction equal to 0.013 here, 0.013 millimeter. This is the solution for the first bit. Deformation, see in x direction very little, 0.14 millimeter of 0.1. In y direction it is 0.00 in y direction, but in z direction also 0.013, only the considerable amount of deformation. So now if you come to the second bit, what he is asking second bit, change in volume. How we need to proceed for change in volume? So we know the formula, volumetric strain. We need to apply for volumetric strain. This is for second bit. The volumetric strain equal to, I'll write volumetric strain equal to change in volume divided by original volume, right? That is change in volume divided by original volume. Okay, so he asked change in volume. I need this one. Change in volume is total volume. Change in volume, how much? This I want, right? This one I need to calculate how much. For that we need to check this one. First, original volume, we know that we can calculate. The original volume equal to how much? Length into width, width into thickness. 200 length, width is 80, width is 80 millimeter, and thickness is 20 millimeter. Okay, this you can calculate here, the volume. Next, how to calculate strain in the volumetric strain? Volumetric strain, can I write it? This volumetric strain is strain in x direction plus strain in y direction plus strain in z direction. Can I write that one? Yeah, I can, because strain in x direction plus strain in y direction plus strain in z direction. All together it is total volume change. So strain in x direction, we already calculated how much in before, that is 68.6 into 10 raised to minus 5. This is strain in x direction, plus strain in y direction, how much it is there? Minus 40.35 into 10 raised to minus 5 in y direction. We already calculated before. Okay. Next, strain in z direction plus strain in z direction is 15.75 into 10 raised to minus 5, right? Into 10 raised to minus 5. So this one, after adding all those things, I got this one, that is 44 into 10 raised to minus 5. That is volumetric strain. Now substitute this value here and V here, total volume here, you will get change in volume. Okay, so substitute this to here and this to here. Okay, therefore I will write this, the left side 44 into 10 raised to minus 5 equal to this, equal to, I want the change in volume divided by original volume is 200 into 80 into 20. Just simplify everything, we will get total volume, change in volume. Change in volume equal to 140.8 mm cube. See, the total volume change after applying these three stresses, mutual perpendicular directions, in we'll get the 140.8 mm cube. Okay, this is how we need to calculate the unknown datas.